Okay, this is an edit to the last video I made because I made a very common mistake. So in this problem, find the volume of the solid formed by revolving the region bounded by these graphs and about the y-axis. So we always want to start by thinking about what our graph looks like. And I know we have that picture there, but we're going to look at it again. So I know y equals x squared plus 1. That's a parabola. It opens upward. The vertex is at 0, 1. And there we go. There's my first graph. The line y equals 0, well, that's the x-axis. X equals 0 is the y-axis. And x equals 1. So one thing to think about is where we intersect here. This point here is 1, 0. This point here, well, where does x squared plus 1 equal 1? Sorry. What does y equal when x is 1? 1 squared plus 1, which is 2. So that's 1, 2. All right. So the region we want is this piece right here. We're going to take that and we're going to rotate around the y-axis, which means we're integrating with respect to y. When we find volume of something with a hole in it, because we're missing this piece right here, we take the outer function minus the inner function. We take pi times our integral of the outer function squared minus the inner function squared. And in this case, it'll be dy because we're going about the y-axis. You may think this problem, okay, well, in terms of y, this is a radius of 1 for the whole thing. And in terms of y equals x squared plus 1. When we solve that for x, we get x equals plus or minus square root of y minus 1. So you may be thinking, okay, well, it's just the positive part, so square root of y minus 1. But that is actually the common mistake that I fell into. Because the square root of y minus 1 doesn't exist in here. Which means we're trying to take a square root of something that doesn't exist. Which makes it impossible. So this will actually give us an answer, but it'll be a wrong answer because basically we're making assumptions that don't exist. So what we need to do is break this into two parts. Where does my top function begin? This bottom part here is a pretty simple area. It's just disk method. We take pi times the integral. We're integrating with respect to y, so we'd go 0 to 1 of the radius squared, dy. Well, the radius in that case is just 1. Plus pi times, now we deal with the part with the hole in it. So we take our outer function, which is 1 squared, minus the inner function, which is square root of y minus 1 squared dy. Our bounds of integration there, well, y starts at 1, ends at 2 because that's that intersection we found, so 1 to 2. It looks very similar, but we cannot just add those together because this first part does not deal with the square root of y minus 1. Because it does not exist there. If your function doesn't exist there, you can't use it. So we simplify this. So we have pi times the integral from 0 to 1 of 1 dy plus pi times the integral from 1 to 2 of 1 minus y minus 1 dy. And one step further on this before I do my integrating. I'm going to take and actually simplify this. So I actually get 2 minus y dy. All right, so now the antiderivative of just dy is y. So I have pi times y from 0 to 1 plus pi times 2y minus 1/2 y squared from 1 to 2. All right, pi times y from 0 to 1, we take 1 minus 0. plus pi times, if I plug in 2 here, I get 4 minus 2. minus, plug in 1, I get 2 minus a half. So, oh my, sorry. There we go. So I have 1 pi here plus 2 minus 1.5, which is a half. So pi over 2. And pi plus pi over 2 makes 3 pi over 2, which is the actual volume. If you did this original wrong way, you actually get 2 pi as your answer, because it's accounting for something in here extra that doesn't actually exist. So that is my correction for you.